everybody. Welcome to our morning session about cloud native. We started yesterday with the future of Java being serverless. Today, we started with Kubernetes native Java. So I think it would be great if we talk today about cloud native and how we can understand it better. Just to introduce ourselves, I'm Anna. I'm currently working as a developer advocate for Red Hat. Been with you yesterday as well, and I'm really happy to be here today again with you. And together with me is...
My name is Rustam. I have been to in Romania to Vox Days for quite a few times already, and it's really happy to be back again, even though it's virtual again. But hopefully we'll get to do it in person next time. I work in a company called Compitas. We also have an office in Romania as well, but I work in the Norwegian office, and I am also a Google developer expert on the topic of cloud, and also together with Anna, with both our Java champions as well. So we going to talk a little bit about all this fun things related to understanding or misunderstanding cloud native. So everything we're going to tell you today will have one answer. It can have one answer, not will, but it can. And this is probably the answer that you do not want to hear, but very often it will be that. And that short answer is it depends, because it will depend on a lot of different factors, and we're going to try to talk about those factors, and we'll try to weigh in different options and views to those things. But it might be your mileage may vary. So that's kind of the short version, and bit kind of joking introduction, or with a little bit of a joke, I guess. But if we go to a bit more serious business, so we can, I guess, turn it around and say, well, it's a kind of a disclaimer, and that disclaimer basically says that every decision has a quantitative and qualitative pros and cons. So, one thing is it depends. The other thing is, all the choices you make will always have pros and cons. So you need to weigh them and see which one is heavier and bigger and stuff like that. All right. When we talk about cloud native, we probably need to start with a definition of cloud native, what actually we mean by cloud native. And to help you with that, we pulled out to the slides a wall of text. That is a very good definition provided by CNCF, so Cloud Native Computing Foundation, and that's the official definition of cloud native. But since you're not supposed to show a wall of text on the screen, and you probably, I hope not, but probably most likely you were way into the text and you forgot about what I'm saying and you're just reading the text, I kind of help you with that. So we highlighted the most important words, and to disrupt you from reading the text one more time, we removed all the other words. So now we have the main keywords that we need to help you with understanding cloud native. So it's a scalable application, public, private, hybrid clouds. It's a container, service meshes, microservice, immutable infrastructure, declarative APIs, loosely coupled, resilient. All those words. If you do not know some of those things, or all of those things, or you don't know all those things, doesn't really matter. Don't worry, we'll talk quite a bit about most of them. To help you a bit even further, we decided to split it into three. Sorry, counting off by one errors. We three categories. So what, how, and why. Right. So what we're going to build? Well, we're going to be building scalable applications on private, public, private, and hybrid clouds, or one of them, and one of them. Depends. How we're going to do that? Well, we're going to use all those techniques and tools for us. And why on earth do we really want to do that? What's the point? I mean, okay, it's cool, but there should be a reason for somebody to spend their time, money, and resources implementing that. So minimal toil, predictability, frequent changes, all those kind of things really is the motivation for doing that. All right. Now that we have a bit more of the common understanding of what as cloud native actually means, let's talk about the common misunderstandings of those things, right? So one of the first one out is for you, Anna. So does cloud native mean I have to deploy all my apps to the cloud?
Well, the answer to this one, besides it depends, would be um, yes. But let's look to the definition again. And the common misunderstanding that is probably with many developers is that the cloud means that you have to deploy to the public cloud. But if you look at the definition that the Cloud Native Computing Foundation is giving to us, it says that, hey, you should build scalable applications, first of all, like focus on what you're building. And then you should be focused that you could deploy those in any of the public, private, or hybrid clouds. So this kind of gives us a lot of options in terms of using the cloud to put our cloud native apps. And furthermore, if we're looking to the what, meaning where are we deploying these three options mean the following. So cloud can be public or private. When we're talking about multi-cloud, most of the time we're thinking about public clouds offered by different providers. And when we're thinking to hybrid cloud, there's a combination between public and the on-prem version. And then you can have some combinations like, say, the old and the new. But all of together of this, there are multiple ways to achieve being cloud native and being a good cloud native citizen without struggling too much about the cloud means always public. And furthermore, if we're looking to the paradigm of what the public and what the offerings of the cloud are giving to us, you need to take some decisions. And for example, in the slide, there's this kind of decision to look into a cloud offering that is matching your workload. And often you are taking this decision based on amount of resources that you will need. If you are perceiving that what you're going to deploy in the cloud is something that's going to oscillate in time in terms of workload, and you cannot predict that part all the time. You don't know what's going to be there for you. It can happen, in terms of when you're building new applications, you don't know how much workload those will receive. So it would be better to rely on the cloud provider. But if you can predict the resources that you needed by the applications, because maybe you have some legacy app that you built some time ago and you are modernizing that one, and also you would like to keep some good security around it and have things under more of your control, you can opt for a private cloud option. And when you can partially predict the application needs, well, the hybrid cloud is the best option available there for you. So please think about this when you're making your decisions based on amount of resources. And furthermore, looking into the cloud saga, let me ask you something, Rustam. A lot of folks, I've seen vendor lock-in all over the place in the past years. Kubernetes itself was invented so that it can be cross-platform, so you can move your workloads easier. What is this? What's your opinion about this misunderstanding of the vendor lock-in? Should we always be afraid of the vendor lock-in?
Oh, it's a really, really fun one, because I hear it in very different kind of shapes and sizes and flavors, this kind of thing. So usually it would be maybe we shouldn't use a specific managed service on a specific cloud because, oh, wow, it's going to give us a lock-in. Or sometimes people talk about using just deploying things to the cloud. Oh, well, it's going to give us a lock-in and stuff like that. So it's a different sides and different ways of being afraid of that. But our point is that you don't really have to. So it is a misunderstanding, and it is that vendors provide a service, and usually you would look for two different kinds of service. One is a super open source based, open standard based kind of solution, basically managed by somebody else. That's really nice. And there will be also another one that will be very proprietary and quite closed based solutions, also offered on the same cloud, maybe even solving similar problems or similar kind of niche of functionality. And then, if you have to choose between those, obviously you now I guess you guessed pretty well where I'm going with this. You should probably and most likely go for this open standards and open source software, because then you can actually migrate between different cloud, even though it's a managed service. So say, I don't know, a Postgres database managed by somebody else. You don't have to put a Postgres on a VM and put it on the cloud just because you're not going to be dependent. Now you can take your VM and go somewhere else. You can actually use the managed service because, well, it is a standard Postgres database. You can actually export and move it to if you have to. And then you have to also weigh in things, put into this equation things that talk about whether what are the possible, I mean, what's the likelihoods of you moving around? So I mean, okay, cool, it's good to avoid lock-in, but what is the chance that you will have to move in, or if you will be actually able to move in at some point, right? And the last thing I probably need to mention about this is that lock-in is actually kind of a weird animal, because it's you can end up with a lock-in with pretty much anything. So cloud is not really the most scary thing. I mean, choosing a language or a platform or a library if for your project might also lead to some kind of lock-in. So, we always do this kind of things. We often do this thing. So it's not as scary as it might sound. Anyway, let's go back to another misunderstanding, or go further to another misunderstanding. Let's talk about lift and shift compared to a kind of further development or development of your application. So back to you, Anna.
Well, in case of these two, there are actually ways to modernize your apps to be cloud native. They're not necessarily a misunderstanding. However, the way that they get to be implemented, that's a total different story. So let's go back to the definition that we were looking earlier, and also look to what is misunderstood. So the misunderstanding that exists and has been for a while is that if you containerize any legacy app, and then you have modernized it. Well, lifting and shifting actually is intended to modernize minimally the application architecture. So that's one thing that you should know. So what it means is most of the time a replatforming of what you are doing. It doesn't mean that you should go and lift and shift everything that you have there, because you need to also have a good analysis of what you did over there. And there are tools that can help you to do that. Many providers can offer you these kind of tools to assess the current state of your legacy apps, and afterwards give you some ways to migrate those apps. It can be lift and shift, or it can be any other options as well. So when you're looking to migrate, we're looking to do the lift and shift, first of all, gather all around this developer team, not only developer team, architects, QA, everybody who's involved in developing at a certain point an app. Analyze the source code of the existing artifacts that you're having. Plan and estimate the work of the lift and shift. It's not coming for free. Now it's like this, oh yeah, today we're running here and tomorrow we're running somewhere else. You have to be a little conscious about the change there. And then use the tools with built-in rules and migration paths. They can do some work for you, and use those so that you don't end up with thinking the migration path by yourself. You can do that as well, but why not cut to the chase and look into coding and doing more fun stuff. Also, you can identify migration issues and evaluate solutions, because the tools, they give you migration paths, but they're learning as well. So they do know a few things, but they don't know exactly the background of your apps. And then containerize existing application components while you're keeping data and integration parties on legacy. So when you're lifting and shifting is a gradual process as well. It's not something that is like you're smudging something from the ground and then that's it. It's moved another way. And typically this kind of lift and shift is happening on a platform as a service offering. And probably you would see, if you're doing some research about people that have tried lift and shift, you will see this in their examples, like, hey, I deployed to this, and they name the path that they used. But furthermore, there are other options as well. And you can boost your applications with new layers. So another option is to wrap your existing legacy apps with new layers like APIs or interfaces, and you deploy these on a platform as a service. So they're like an intermediary to what it used to be, and they can give you a boost in modernizing what you had for your stack, but also they can give you a boost in performance. And this is actually a path if you want to get to the third one, which is complete rewrite. Now, complete rewrite is something that we take, I think we as professionals, maybe we take it very hard, because if we're working on a product for many years, you kind of invested feelings in that one, regardless if sometimes you were not feeling that great when you were developing with it. But you're invested in that. It's your child. As a developer, as an architect, as a QA, you grow up. You grew up with that. You raised that. So it's hard to rewrite that, not necessarily because there's a lot of code and all this, but it's hard because you care. It's the same with the technology. It's hard to change a technology to a new technology just because it's shiny. You have to really feel the connection with that. And then in this case that you want to rewrite, and rewrite would be recommended, you have to rethink how the platform actually was architected before. So always understand the past before going to the future. So understand the past, understand what was not so great in that past, and what good the future will bring to you. Otherwise, all this struggle of rewriting might end up with something that you would be happy and you would feel fulfilled at the end as a team, that you have done something, not to mention the business, because they probably would be like, oh my God, we spent so much time into building this, but it's not producing the expected results. Of course, rewrites bring a lot more pressure on teams. However, they can bring more satisfaction in terms of learning, in terms of building something new. So it's an excitement of building something new, building something better, and new connections. So those being said, let's look into something else regarding cloud native, because we talked about different ways of going and of modernizing the app. And yesterday we talked about serverless. So how about going serverless, Rustam? Is that better for all of us?
Oh, hey, that's also another fun thing, right? And first, before we go there, I really like this kind of, the human feeling and humanizing the apps and feelings and everything. The way you talked about it was really, really fun. And it is actually kind of true. You get grown and attached to things. And then, talking about serverless, it's the serverless is good. Service is amazing. Services is awesome. Serverless. But the misunderstanding here is that, if I go serverless because everybody else is doing that, I will have some benefits just out of the box, and that is not necessarily correct. So so it is a good thing. It is a good practice. It is a good way for its use, but it doesn't mean that you're not going to have servers. Obviously, you'll still have servers. It's that it probably should have been called manageless, I don't know, instead of serverless, if we could redefine it again, or create a new name. I guess it's not as cool name as serverless, but it's more descriptive, I guess. But anyway, so serverless is a cloud native development model that allows developer to deploy and run their applications without having to manage servers, right? So there is no management, but there are still servers, there are still applications, there are still things. And there are a few things connected to it. So one thing is that do I have to run things on a cloud, any cloud, to use serverless? And the answer is no. So you don't have to. You have different ways of doing that on-prem. So there is the things like Knative. There is Quarkus has a thing that's called Funky. There is some other functions as a service and all those kind of things. And it doesn't really have to be a tiny little function as a service. It can be also a containerized application as a service, preferably stateless application. But there are also some ways of doing that with the stateful as well. But that will add you a bit more of complexity and everything. But serverless can be a good thing. It has a lot of positive things. You kind of spend less money if you're running on the cloud. You're spending less resources if you're running on-prem, all those kind of things. But you still, if you have to rewrite your application, you'll still spend quite a some time and resources to do that. And then you have to think about whether that time is well spent on this, or you should spend it on something else. So, your mileage will and can vary, and it depends, and all those things, right? But there is a ways to evolve your implementation, right? So you can and that goes actually with both serverless and also regular applications. At least the first point, where you can and should use some kind of infrastructure as code tools, for example, Terraform, Pulumi, or something like that, to run and build your application and to create environment for your application. And that can be on-prem, that can be on a specific cloud, or any cloud really. So then you can actually move around or redeploy or create new environments even for your implementation and your serverless implementation, or actually in this case, it can be anything really. Another thing is that if you want to run things on Kubernetes and you still want to use serverless application and stuff, you can consider looking at Knative, which is an open source initiative, an open source platform for running serverless applications based on Kubernetes and Istio and all those things. One of the things that people really often ask when we talk about serverless and everything is that, okay, cool, serverless is good. I can put it somewhere. It will scale up and down. It will fix all those issues with the number of hosts or servers hosting it, and so on, so on, so on. But can I run it locally? I really want to do that, to make that run and develop things first before, otherwise it's kind of boring. You have to write your code, you have to deploy it somewhere, wait for it to deploy to a cluster or something, and then you can test it and everything and things like that. And the answer is yes. There are different ways of doing that depending on the platform and everything. So you can use very often, it's kind of almost more or less expected from providers to provide some kind of emulators or CLI clients to simplify that job. And when working with Knative and Kubernetes, some also teams utilize environments that are, quote local, which is not local, but kind of behaves local-ish. So, for example, there is one from Red Hat, OpenShift Sandbox, but there are different options for that as well. There is some things also on, I know of some things that will do the similar things for Google, and so on and so on, right? Speaking of Kubernetes, speaking now that we've mentioned Kubernetes, let's talk about another thing, is that, we don't want to use a Kubernetes on the cloud because it's managed by somebody else, but I better do Kubernetes thing myself, and run all the clusters and nodes and master nodes and all those things locally, and manage all that, and everything will be shiny and full of rainbows and unicorns. What do you think about that, Anna?
Well, the do-it-yourself Kubernetes service platform is something that I've noticed it ignited with the folks that had already a data center, or they already had hardware that could use it. So they wanted to put to good use that hardware. And if you're looking to the mirage of Kubernetes, I mean, it looks manageable. And it is a great platform that is extensible, and it is great to be extended. However, working with it, as I recently saw in a tweet about intended for developers, like what is bothering you when you are developing with Kubernetes and so on, what many people said is that it takes some time to understand the platform. So there are many API versions. Not all of them are, just V1 or V2, or actually just V1. Some of them are in alpha, some of them are in beta. You have to be very careful how you're working with the objects that are available in Kubernetes. But Going back to the do-it-yourself Kubernetes service, this has been an option when Kubernetes has ignited itself. I'm not sure that nowadays is still something that people would like to do, because there are many stories and many lessons learned from others that kind of say what their struggle was. However, let's look into detail what the do-it-yourself Kubernetes story is looking like. So for each cluster, you have to do these small, actions, which are not actually small. I was just kidding earlier. You have to use deployment tools like kubadmin or kubespray. This is the great scenario. I mean, I'm going to mention here only tools and things that are open source, and they're kind of coming with the platform itself, not tying to any provider. Also, do-it-yourself Kubernetes was ignited from the idea of staying agnostic from any provider. But look at these actions that you should do, like use deployment tools like kubadmin or kubespray. If you didn't try them, you can still try them. They're available over the internet. You just need a piece of infrastructure, and you'll find the rest of it, the installation details, in the kubernetes.io website. It's fun if you want to try it a few times, but if you're thinking to scale this, it's not going to feel so fun. Then you have to configure this for high availability. So you have to configure for high availability. This means that you have multiple contra plane systems. This is meaning that you have to think for backup and restore of etcd, multiple etcds, not just one, because you want to be able to restore the state of your system consistently. Then you should manage certificates and secrets, because security is very important. Kubernetes is coming with abilities as a platform to help you with those, but you still have to provide a way to manage those. Then you have to configure external load balancers for the API server, assuming that you would like for the world to have access to what you're deploying, and many more. And then you have to think of the managing network policies, ingress and egress. And that's why, for example, some other options and some other custom resources have been invented by different providers. Or, for example, in OpenShift, there is the concept of route, which is kind of simplifying the ability to simplifying the ingress part for the end users. All in all, Kubernetes is great as a platform. However, doing this by yourself, and by yourself I mean doing this as a team by yourselves, in time is going to add up with a lot of work that probably you don't feel that you could invest it into maintaining this, and you would end up to the part saying yeah, probably would have been easier if I would have used OpenShift or another provider's Kubernetes service, and some of these would have not been known to me, and that's it. Imagine how much time you're saving after not doing these things and somebody else doing these things for you and taking care that they're working to the ladder. Furthermore, if we're thinking to more stories about should you do it, well, if you're looking to the CNCF definition of cloud native, it says that combined with robust automation, what you're building as a cloud native application should you should be able as an engineer to make changes frequently and predictably without, affecting your end users. So if you probably remember the last slide, it was kind of cluttered with a lot of actions. If you feel great, also developing and deploying and managing that, and automating that, of course, then the answer could be yes. If not, the answer is no. So always put in balance these things, that you have to automate what I showed you earlier. It's not something that you're doing it from time to time, because you as engineers, you have to invest your time carefully in doing things. And I think that our world of IT has been focused for a long time on how to, do not have these time spent on operations that are not okay, are just time consuming, but are not bringing any benefits to us or to the organizations that we're working for. And since we talked about the do-it-yourself Kubernetes and the Kubernetes cluster and modernizing applications, No, you don't always need a Kubernetes cluster for every application. It depends on your use case. You don't always need to, to follow a certain pattern just because you saw somebody doing a nice and shiny demo. It worked for their use case, might not work for yours. So always do an assessment of what you're having and see if you really need that. And you can find over the internet examples of people that for portions of their platform, they decided not to go with that one with Kubernetes, and they tried to really replace that with other kind of platforms because it suited better their type of architecture. So don't try to use Kubernetes for everything, because you might end up realizing that managed services or any other things could have saved much more development time or much more time and provided a better performance for your application. And now that we spoke about Kubernetes and all of this, and we spoke about deployments, how about continuous integration and continuous deployment, which most of the time, are thought like you script this once and it works under any condition. So it's like a dream come true. What about that, Rustam? What do you...
Well, I mean, probably the giveaway is this tiny little fine print under the headline, right? So it isn't a misunderstanding. I mean, you cannot write script once and just expect it to be there and work forever and ever, like pretty much like with everything else we do, right? We always have to maintain things. If you build a bridge, you need to kind of, go and check if it's still working and there is no cracks or anything like that. Or if you build a building, do the same. And if you write the code, you need to do the same. So why not doing the same thing about your CI/CD pipeline? So it will be implemented mostly. I mean, most of it will be probably developed once, but then it will be tweaked and evolved at various times through the life of that project. You might get new servers, you might get new services, you might get new different, very, very, like all kind of reasons for that, right? So this timeline of engineer doing something and it ending up in a production, it's kind of a straightforward pipeline, but there are a few kind of ways, loops there where you can actually go back and test things and kind of continue that. And then, so for example, you do your code and then you go, so engineer commits code, it goes into test, it might go back to an engineer because it needs to be fixed, something else or something redone or something failing, whatever. It can also go to review and then go back, and so that's one thing, right? And the other thing is that your CI/CD pipeline will very, very likely will change depending on as your application is changing. And that's another kind of misunderstanding, in the sense that people don't want to spend too much money or resources or time on maintaining and making that CI/CD pipeline modular, maintainable, and so on and so on. It's more kind of, oh well, we just needed to make it work and then we fixed it, and we don't want to spend more time on that. But then maybe you should do that. Maybe you should use some things that will make your life easier. I don't know, feature toggling, for example. This is not direct CI/CD thing, but it will help you with, deploying new features or activating new features without needing to go through CI/CD, for example, and so on, right? So how we can build resilient pipelines? What are actually resilient pipelines, and how do we get there? So this is a kind of set of things that might be good to do. You don't have to do all of them, but look into those. So if you do those things that I'm going to mention now, your pipeline most likely will get more resilient. So shared responsibility is a very important thing, because it's not one person that does all the building, so kind of Bob the Builder kind of thing, or whoever else, just kind of the cartoon reference thing. But shared, it's everybody's responsibility. Long story short, right? Everybody is responsible for making sure that CI/CD is okay. You changed something, it will break something, or you see it broke something, please go and fix it. The other thing is that, like I said many times, the pipeline will evolve with your features and processes. Merge to main as often as possible. So do not do like crazy feature branches that live forever and ever and in the different parallel universes and realities, because you will get, if you've seen enough sci-fis, you know that, when you merge different universes and parallel realities, things collide, things go bad. And this is what happens in CI/CD pipelines. Now I managed to put in sci-fi into a talk about CI/CD. Congratulations to me. And then, well, you can also do run all these automated tests. You do quick feedback loops and all those kind of things. And then you can also do frequent and small deployments and to all of your environments, not only to production. So treat all your environments as you would treat production, more or less, because you will see errors, you will see things failing much, much, much earlier. I mean, it's really fun to have surprises on a Christmas Eve or whenever you get your presents, but the bugs are not that. You really want to get them often. You want to kind of fix them fast. Observability. So observability is an important thing, but there is a misunderstanding here as well, and that is when that observability is important after we're reaching production. So what do you think about that, Anna?
Well, I've seen this talked a lot of times that we should, after you get to production, you get into live, people are using a system. That's when some folks are thinking, hey, we should observe how that is behaving. However, observability is not something that is to be done after a system is live or after a system is getting into production. Observability is something that we should look into step by step through every environment that is available there. The reason why I'm saying this is because most of the time when you're starting an app, working on a feature, working on an application, what happens is that there is somebody from the business side saying, I want this to run 24/7, for example. I want this to be available only for a certain region or things like this. So these kind of requirements kind of tell you that you should observe your system so that you know that you actually met those requirements. Because one thing that I was asked in the past as an architect, I was asked, like, how can you prove that? Because you need to prove those numbers that were asked from you, that the implementation is actually doing that, is 24/7, is it for a certain region, and so on. And just saying, just giving your word is not enough. People need to see something that is concrete and something that is mathematical. In the end, we are engineers and we do work with maths and with numbers. So looking into observability and its importance to make a system observable, you can use instrumentation methods that include open source tools. And you can look at the open telemetry and you'll find tools, methods, practices for a lot of programming languages, not just Java. And open telemetry is a great place to look into and see that this is actually this is not just a specification, this is not just a guideline. This has actually been intended as a unified place where you can take some notices, some ideas on how to make your system observable. In the past, I used to look at the Open Tracing Initiative, which some tools were aligned with. However, there was another initiative called Open Census. Some other tools were looking into that kind of standard. And if you were trying to migrate from one to the other one, and you could end up with some mixtures. What Open Telemetry does is combining the best of the both. Now there are ways to breach things there with shims. And many more. And you can make your system observable by collecting logs from your systems and make sure that those logs are, not logging any sensitive information of your users and so on. You can collect metrics, because metrics are going to actually support you when proving that, yes, your system was running 24/7. Actually, it had the downtime of 0.0000000, very small amount of time during the year of downtime, because okay, there's no such thing as perfection, and Yeah. And of course, traces that are helping you into realizing what happened at a certain time with the transaction. We can identify how your transactions are performing and trace how a transaction performed across multiple microservices, for example. And last but not least, user feedback, because we can build so beautiful systems that we're proud of, that we make the best patterns in the world in it, and we utilize the latest Java, the latest React, Vue, or Angular framework, nice UI, and so on. But if end users are not there using that system, then it's not that fulfilling as we expected. We always have to care about user feedback, and there are ways to look into the user feedback in terms of how often certain areas of what we built are being accessed, how much time it took for the users to complete certain flows, because we actually build flows of actions with our application. So if a flow that was, intended to last 3 minutes to help somebody, because that's why we build IT applications, to help people, and it took longer than 3 minutes than was expected, then maybe we should revise what's going on there and maybe re-implement what's going on there and retweak it. And that's how you get to more innovation for your apps. And with that being said, we're getting close to the end of our session, and we would like to thank you. You can find us on Twitter, and we're really happy that you have welcomed us here today. And if there are any questions, we can answer them now.
Looking forward to that. Thank you very much to everyone listening. Back to you, Andre.
Thank you. I don't see any questions in the chat.
Okay, that's cool.
Sounds good. Well, then let's do it on Twitter then. I mean, feel free to DM us or do it publicly or whatever, and then we can talk and discuss things. And hope we gave you a little bit of food for thought for deploying your next cool and shiny application.
Yes, the cloud native subject is an endless one in our opinion, and we can talk about that one and talk about all the advantages and disadvantages over it for hours, I think.
We can probably do whole day session about that, I guess, and still be not done with it. So.
Yeah. Yeah. Well,
Thank
in
you.
this case, thank you, Andre, for hosting us.
Sorry. Go ahead. Sorry.
Thank you, Andre, for hosting us. It was great to be here. I was kind of a little nervous in the beginning that if we're all going to fit, but I like this kind of approach, 3 speakers, slides.
That's really fun. Thank you very much for the session. I really liked this and really loved being back in Romania. At least, like I said, virtually, that's the best thing we can do right now. But yeah.
Yeah, I hope to. Well, I know I'll be for sure back to Romania, but in other circumstances. However, I hope for us to all get in person really, really soon, and be able to talk more in person than just via chat or via online sessions. So yeah, enjoy the rest of the conference, folks. It's gonna be fun, and yeah, stay till the end. The end note is gonna rock.